to run through an example of a tangent line approximation problem. These questions get worded a lot of different ways, and they're all the same thing. They might ask you to approximate a value of a function using a tangent line. They might ask you to find a linear approximation. Sometimes it's called a linearization of the function. You might even occasionally hear it called a line of best fit. Okay, all of these different things would kind of fall in the same category. Anyway, the big idea here is you can really just use a point slope form of the equation to write this. And books will give you different versions of the same formula, and some will actually give you different formulas for different wordings of it, but they're literally just all the point slope form equation. So of course you all know point slope form is y minus y1 is equal to m times x minus x1. And that'll work just fine for these problems. So notice here, they give you a point. This is a function that passes through the point 2, 1. So we know that when x is 2, that y is equal to 1. And we can go ahead and fill that into the equation right off the bat. Now, the last thing we need here is the slope. Okay, well, they give us a slope, maybe a little bit hard to read here, but they say that f prime of 2 is equal to 4. So the slope is 4 at this particular point. So we can put this in right here. And so my final equation is y minus 1 is equal to 4 times x minus 2. And, you can put it in slope-intercept form if you want to. A lot of books at least would probably have you solve for y and maybe move that 1 to the other side. Anyway, you can end up with something like 4 times the quantity x minus 2 plus 1. And anyway, at this point, you should just be able to substitute in here and figure out what's going on. So in this case, they want me to find f of 1.9. So I'm just going to substitute 1.9 in here. And by the way, if you don't simplify, a lot of times these are going to be easier to work out because you're taking 1.9 minus 2, which is going to give you negative 0.1. 4 times negative 0.1 is negative 0.4. And then you're adding 1, and you're going to get your y value here. And in this particular case, the y value is going to be, in this case, the y value is going to end up being 0.6. Okay. By the way, what's really happening here is when you take this 1.9 minus 2, you're actually finding the change in x. So we're saying you're going back a tenth. And if you're going back a tenth, how much do you expect your y value to decrease? Well, if you take your slope and you multiply by your change in x, then the slope is 4. If you go back 0.1, you're going to have a decrease in y of 0.4. And then that's getting added to your initial position at 1, which is where you started in the first place. Okay. By the way, if you want to actually take a look at a graph of this, you can also kind of see what's going on here. In a graph, what's really happening here is you've got some kind of a curve. Let's see if I can delete enough stuff here to actually show that. What's essentially happening here is you have some kind of a curve, and got this line coming in. And, I don't know exactly what the curve looks like, but, let's say the curve is doing, this sort of thing. And you've got this point here at 2, 1, and you're writing the equation of this tangent line that comes in there. And, in this particular case, we wanted the value of f of 1.9. So we're going to get this point here at about 1.9 that's just a little bit down the curve. And that's what ends up happening there. So these questions can be very simple. Again, the wording can be a little bit different, but you can always fall back on point slope form. You don't really need different equations for different wordings of these problems. And they can be really, really nice to work with.